Hello, welcome back. So we continue, right? So we said atomic structure. So we are continuing, right? So in case you just come, please check the previous video on the introductory lecture. So we introduced atoms and everything. So now we are going on to talk about atomic structure. So what constitutes an atom? So what constitutes an atom is you're going to have the nucleus and then you're going to have shells that surround the nucleus, right? So what happens is that you're in that nucleus, you're going to have the protons and the neutrons. So what's going to happen there is that think of it like that, and it's even shown there. So you've got the nucleus, there are protons and neutrons, and then there are shells around them, right? Or more or less you can call them orbitals, but that's what we'll call them when we go to as we proceed. But for now, just think of them as electron shells, right? In short, this is where the electrons are. So when you talk about that, so what's going to happen is that, as the name suggests, electrons, these are negatively charged, right? Think about electricity, so electrons flowing. So when we talk about the atomic structure, that's basically what we have. So you've got a nucleus and you've got shells around it. So the nucleus, just to go about it once again, has got the protons and the neutrons, and then electrons are around orbiting around the nucleus in the electron shells. Now, you want to know something about the charges of these. So the protons, these are the ones which are positively charged. The neutrons, as the name suggests, neutral, right? So they are neutral, so they don't have a charge. And then the electrons and the negatively charged. Now, what's interesting here is that here we are going to learn two new terms, or maybe you may have already gone through them in high school. So we're going to go through the terms atomic number and mass number. So what's atomic number? Atomic number, this is the number of protons that an element has. So what an atom has, if you put it that way, yeah, better put it as an atom, right? So an atomic number, this is the number of protons that an atom possesses, okay? And then when you talk about the mass number, that's the total mass of that particular atom. Now, I would want to state here that even though we are talking about the total mass of the atom, we know that an atom has got three parts. It's got the protons, the neutrons, and the electrons. But because the electrons have got a very, very low mass, so much that even if we added the electrons, it wouldn't really affect, the weight or the mass of that particular atom. So by convention, what happens is that to find the mass number, what we do is you calculate it by adding the protons and the neutrons. So the mass number is protons plus neutrons, not including the electrons. Reason being, electrons have a very, very low mass, and so they wouldn't really affect it much. Now, whenever we have a neutral atom, so remember that atoms, okay, if an atom is neutral, then it means that it's got an equal number of protons and electrons. Because remember, protons are positively charged, electrons are negatively charged. So what that entails is that if it's to be neutral, then the positive and the negative have to be equal, right? Perhaps you agree with me. So what happens is that if the number of electrons increases by an atom gaining, okay, an electron, and we'll talk about that when we talk about bonding, ionic bonding, and all those things. And then so that usually occurs in terms with non-metals. But then when we talk about metals, metals are prone to lose a what? To lose electrons. So when it loses one or two electrons, or three perhaps, like aluminium, what's going to happen is that you're going to have the number of protons is now higher than the what? Than the number of electrons. So that's why the positive charge is going to be there, because the balance has been lost. Now, this is really, really interesting, because one thing that we know, and just to mention, of course, we know that because atoms are very, very small, so they are measured in atomic mass unit, because we can't use grams because they're just really, really small, right? Atoms are really, really small. Now, one thing about this, then what really differentiates atoms? Because, we've already talked about the fact that these particular atoms, they contain protons, neutrons, and electrons, and all of them contain that. But what makes them different? Here, well, what makes the difference is the fact that these particular electrons are going to have different numbers of protons, and because they're going to have different numbers of protons, that means that they're going to have different numbers of what? Different numbers of electrons. And remember, electrons, as we'll discuss later on, they are the ones which are involved in reactions and everything. So that means that when that reaction is taking place, because of that, because of those number of electrons which are different, that's why even these particular atoms are going to behave differently. So basically what makes one element different from the other, one atom different from the other, it's all about the number of protons. Because remember, in a neutral atom, the number of protons is going to be equal to the number of electrons. And so if you've got you've got 5 electrons, 3 electrons in your outermost shell, that's going to affect how you react. So that's really basically what makes the difference there. So we really talked about it. Now, before we can conclude and then begin to talk about bonding in the next video. So basically, we've talked about all this, but now there's something that we'll talk about, and these are the energy shells. So about the energy shells, though we'll talk about more on this in chemistry, on atomic structure, but in biology, what you'll be assessed on is just knowing the shells, knowing which is the first shell, how many electrons can it contain, yeah, just things like that. So for naming the shell, moving from the nucleus outwards, you start with the alphabet, okay? So with the alphabetical order. So, but you start from K, L, M, and then you proceed like that, right? So the first one is going to be what? K, isn't it? The second one is going to be L. The third one is going to be M. Yes, you get it right, yeah? Yeah, so that's the key thing. So basically, that's what you'll be doing. So that's how you want to remember them. The alphabet, just starting from K. So please, that's what you want to do, right? Great. Then now you want to know how many electrons each can possess, or each shell can possess. So the first things first, what you want, the first shell can only contain 2 electrons. Then the second one 8 electrons. Then the third one 18 electrons. But to remember that, you can see that formula there. So let me just take my yeah, you can see that formula. If you want, you can pause the video. There the formula is 2n power 2. So n is just the what? N is basically what you are going to be substituting in that formula. It makes sense, right? So that's basically how you want to go about it. So for instance, what is N? Perhaps you may be wondering. N, that's just the shell number. So for instance, K, what's K? K is going to be, N is going to be 1. So if we say N is 1, then square that, you're going to have 1 still. Multiply that by 2, you are getting 2 electrons, right? You go to the second shell, which is L, you're going to get what? N is going to be 2. Then when you square the 2, you get 4, 8, and then just like that, right? So N is the number of shell. So take note of that. Okay, so that's really about it. But so this is in biology. In chemistry, we'll dive into that. So you can see there the N, and then just giving you an idea. So it's important to take note that each successive level out from the nucleus is higher in energy. So the more you move away from the nucleus, the more energy that shell is going to have. And it makes sense because it needs to have a lot of energy to be able to hold the electrons still attached to or rather still connected to what? Still connected to the still close to the nucleus, I should say, because you can imagine the thing is that the further electrons are from the nucleus, the more you want to have a strong attractive pull towards the nucleus. Okay, so just think of it that so that they don't wander away in space. Okay, that's how you can think about it. So now that's really about it. So we've really talked about this concept, and so in the next videos, to just ensure that this video isn't too long, so we'll talk about isotopes in the next video. Thank you.